All right, so the last part of this lesson is the difference quotient. And this is something that you're going to need when you begin calculus. So this is kind of leading us down a path where we're going to learn eventually, right, in calculus, how to determine the derivative of a function. And this is kind of I'll say the primitive way to do that. But again, you'll revisit that later. Right now, we just want to focus on what is the difference quotient. So notice it says f of x plus h minus f of x all divided by h. I'm hoping that sort of reminds you of slope. So just to give you a quick rundown of what this thing is calculating, okay? So I have this line here. I'm going to call this one point. This is x. This point is going to be h away from that one. So this value is x plus h. Okay, so you can call this x1 if you wanted, and this x2. All right, and then obviously this point would be f evaluated at x1 or x, and this would be f evaluated at x plus h. So if I wanted to find the slope between those 2 points, I would do f of x plus h minus f of x, right, the y values, subtracted, over x plus h minus x. And that's going to simplify down to, right, this is going to be x minus x. Those will cancel, and we'll just get h. And that gives us our difference quotient. So this gives us, as it says here, right, helps us understand rates. It's going to be a rate of change, which we know as slope. Okay? So it looks weird, but it really just means, a plug in x plus h into the function, which we've done previously, then subtract from that the original function and divide the whole thing by h. And that'll give us an expression for the slope of the function, or almost slope, I should say. I should be a little careful, right? There is a limit that you'll need to take when you get to calculus. All right. So let's go ahead and say, let's find the difference quotient. So first we need to do f of x plus h. So I'll do this separately first, and then on the next examples, I'm just going to go ahead and plug it in. Well, that means that everywhere I see an x, right, I put a set of parentheses, and I need to plug in x plus h. So this becomes 3x plus 3h, right? I distribute, plus 1. And that's as best as I can do there. All right, now for the difference quotient. So I need to do f of x plus h. That's 3x plus 3h plus 1 minus the whole original function. So that's 3x plus 1 all divided by h. Okay. So what's going to happen? Well, I'm going to get 3x plus 3h plus 1 minus 3x, right? Remember, this is like a negative 1 being distributed here, minus 1. And that's still all over h. Notice we have 3x minus 3x. We have 1 minus 1. This all leaves us with 3h over h. And h divided by h goes to 1. So I am left with 3. So one thing I wanted to point out to you, notice we got 3 and the slope of the function is 3. Okay? Let's go ahead and take a look at another example. Here I'm given a function g of x. Now this function is quadratic in nature, so I may not get something quite as nice, but let's see. All right. So first I need to find g of x plus h. So let's plug in everywhere I see an x, I'm plugging in x plus h. Okay. Now, in this case, I need to take care of what's inside the parentheses first. So x plus h squared. Remember, you can FOIL this, x plus h times x plus h, and you can do FOIL, or we could do our shortcut. It's the first term squared plus 2 times the first term times the second term, right? And plus because there's a plus in the middle. And then plus the last term squared. Okay, and you'll get the same result if you go up here and you do your FOIL. Okay, now I'm going to come back over here, plug that in, and then I will distribute everything. I need to distribute the 3. I need to distribute a -2 there. So this is 3x plus 3h minus 2x squared minus 4xh minus 2h squared plus 4. All right, now if I have any like terms, I would put them together. I do not see any like terms, so I'm going to keep all of them here. Now remember, for the difference quotient, we need to first do g of x plus h minus g of x, and then divide by h. Okay? So I'm going to plug in everything I just found for g of x plus h. That's 3x plus 3h minus 2x squared minus 4xh and so on. And then I'm going to subtract the entire original function. Okay, so that's minus 3x minus 2x squared plus 4, all divided by h. Okay, okay, let's bring all this down. All right, now distribute the -1 here to everything. So it's going to be minus 3x plus 2x squared minus 4. Look for like terms. I have plus 4 minus 4. Those will cancel. I have minus 2x squared plus 2x squared. Those will cancel. And you can call me silly for putting shapes around my functions, but that's one way that I learned to do this. Anything else I have? Looks like I have a 3x and a minus 3x. Okay, so those will cancel. All right, so what is left behind? Again, this is all by h. It looks like I still have minus 3h minus 4xh and a minus 2h squared all over h. Okay. So everything has an h in it, right? I can take out an h. That leaves me with minus 3 minus 4x minus 2h, right? I factored out an h. If you don't believe me, multiply that h back in and you'll get back the resultant. This is all divided by h. And so the whole reason I just did that is now these cancel. And I am left with minus 3 minus 4x minus 2h. And then every single term that's left, you'll notice in this part right here, has an h, because then I can divide out the h, and then I'm left with my final answer here. Okay, so again, when you get to calculus, the last step is you're going to actually let h approach 0. We'll talk about limits a little bit later, I think. And if that's the case, well, 2 times 0 disappears, right? And so, right, just make sure that your last step basically is to cancel out the h from the bottom. All right, I think we have one more example to take a look at here. All right. This guy doesn't look so bad, but I think he might be a little tougher than the ones we just previously did. First, I need to find h of x, and actually, because the term is h, let's do t maybe. Let's do x plus t. Okay, let's switch it up a little bit. Really bad choice of function naming there. So x plus t. All right, so I have minus 2 over x plus t. Okay. Now, for the difference quotient, I need to do h of x plus t minus h of x divided by t in this case instead of h. Okay. So to plug in for h of x plus t, right, I have minus 2 over x plus t. Then I have minus, and it's the original function, which is minus 2 over x. Okay, I got to be careful with those negative signs. Let's just go ahead and fix that part first. So a negative times a negative makes that plus 2 over x. Now, I need to put these two fractions on top together. So I need a common denominator. So common denominator, okay? And the common denominator would be x times x plus t, which means whatever part that fraction is missing, I need to multiply top and bottom. So this becomes minus 2 over x plus t. Now it's missing an x, so I'm going to multiply by x over x. The second fraction has an x already, so I need to multiply it by x plus t, top and bottom. Okay, still all over t. All right. Now I need to distribute that 2 here. I have minus 2x over x plus t times x plus 2x plus 2t all over x times x plus t, all divided by t. Now that they both have the same denominator, I can put them together. So minus 2x plus 2x plus 2t, all divided by x times x plus t, all divided by t. Okay. Now what did that do for us? Well, now we've got minus 2x plus 2x. That's gone. Okay. And if you think about it, that's really the original function being canceled out, right? If I 2x over x times x plus t is really 2 over the x plus t. So that's canceling out that original function, basically. All right. And next, let's see, I have 2t over x times x plus t, all divided by t. Now I'm going to write this as t over 1. So t over 1, if I have a fraction divided by a fraction, I can flip and multiply the fraction on the bottom. So this becomes 2t over x times x plus t times 1 over t. And what does that do for us? Well, now we've got a combination of multiplication and division. If you would like, you can go ahead and put them together first. And now these t's cancel, right? You could have done that back here as well. It's all multiplication division. The t's cancel. And our final result is 2 over x times x plus t. And that is our difference quotient. So again, when we get to calculus, we're going to say let in this case, t go to 0, and that'll give us our slope of the function at any point on the curve. But for now, this is just a rate of change. All right, so that concludes the lessons for week 1. Let me know if you guys have any questions.